Okay, this talk is called Einstein's Relativity, the Misnomer. There is a point of view that Einstein's relativity, his special relativity theory, and general relativity theory are not even relativity theories, that they have been this misnamed relativity, so calling them relativity is a misnomer. That point of view can cause confusion when you go up against people who have the point of view that Einstein's relativity, special and general, are relativity theories. But what do we expect when talking about Einstein's relativity? There is a great deal of confusion, as pointed out in many of my previous videos. People argue from believing special relativity is a relativity theory, but others believe it is not a relativity theory. An example is given at that website there. And at that website it says, in his book, Everything's Relative and Other Fables from Science and Technology, Tony Rothman writes, the term special relativity is probably the greatest misnomer in the history of science. And the person at the website, Joanne Coleman, agrees with him. Amongst all scientific terms, the single word relativity stands out as absolute record holder for triggering an astonishing amount of utter nonsense. And of course that nonsense is generated by people who think special relativity is a relativity theory, talk to people who think it's not a relativity theory, and other such contradictions like that. Different theories are going by the same name. In a related video I've done entitled Relativists in Disagreement about what Einstein's relativity is. In this video I'm emphasizing the misnomer part. Now moving on to general relativity, to point out there are those who believe it's not a relativity theory. General relativity is another misnomer. I'm now going from a paper entitled Notes Success Site Failure, Einstein's Quest for General Relativity, 1907 to 1920, and that's by Janssen Mikkel. Janssen says, in 1905, Einstein published what came to be known as the special theory of relativity, extending the Galilean Newtonian principle of relativity for uniform motion from mechanics to all branches of physics. 2 years later, he was ready to extend the principle to arbitrary motion. He felt strongly that there can only be relative motion, as is evidenced, for instance, by his opening remarks in a series of lectures in Princeton in 1921, published in heavily revised form the following year of 1922. A typescript based on the stenographer's notes survives for the first two non-technical lectures. On the first page of this presumably verbatim transcript, we find Einstein's belabouring the issue of the relativity of motion in a way he never would in writing. And so this is what Einstein is saying. Whenever we talk about the motion of a body, we always mean by the very concept of motion, relative motion. We might as well say the street moves with respect to the car as the same saying the car moves with respect to the street. These conditions are really quite trivial. We can only conceive of motion as relative motion. As far as the purely geometrical acceleration is concerned, it does not matter from the point of view of which body we talk about it. All this goes without saying and does not need any further discussion. and Jansen points out what Einstein says here is wrong. And as I point out in my videos, Einstein is wrong a lot of the time. Jansen goes on to say, although Einstein insists that these points are trivial, we shall see that they are not even true. What makes his comments all the more remarkable is that by 1921 Einstein had already conceded, however grudgingly, that his general theory of relativity, worked out between 1907 and 1918, does not make all motion relative. And Jansen then points out general relativity is a misnomer. Jansen says it has been widely recognised that general relativity is a misnomer. For the new theory of gravity, that was a crowning achievement of Einstein's career. In a paper entitled "Is General Relativity Necessary for Einstein's Theory of Gravitation?" in one of the many volumes marking the centenary of Einstein's birth, for instance, the prominent relativist Hermann Bondi in 19 wrote, "It is rather late to change the name of Einstein's theory of gravitation, but general relativity is a physically meaningless phrase that only can be viewed as a historical memento of a curious philosophical observation." So, in other words, general relativity has been misnamed, but because it's too late now to correctly name the theory, hence it carries on being misnamed. Jansen says the key observation on the basis of which Einstein sought to extend the relativity principle to non-uniform motion is that, at least locally, the effects of acceleration are indistinguishable from those of gravity. Invoking this general observation, a passenger can maintain that her train is at rest even if her coffee spills. She can, if she is so inclined, blame the spill on a gravitational field that suddenly came into being to produce a gravitational acceleration equal and opposite to what we would otherwise have to accept is the acceleration of her own train. So a person on a train and it's accelerating, they don't have to accept the train is accelerating, they can just come up with other excuses. This was the idea that launched Einstein on his path to general relativity, and a few years later he introduced a special name for it, the equivalence principle. But as Jansen points out, the equivalence principle does not make accelerated motion relative, so it's still not a relativity theory. So Jansen goes on to say, this principle by itself does not make non-uniform motion relative, as Einstein came to realise in the course of the work that led him towards the new theory. Two further conditions must be satisfied. For the first of these, that it should be possible to ascribe the gravitational field substituted for an object's acceleration on the basis of the equivalence principle to a material source, anything from the object's immediate surroundings to the distant stars. Otherwise, acceleration with respect to absolute space would simply be replaced by the equally objectionable notion of fictitious gravitational fields. If this further condition is met, however, the gravitational field can be seen as an epiphenomenon of matter, and talk about motion and matter in that field can be interpreted as shorthand for motion with respect to its material source. This condition was inspired by Einstein's reading of the work of the 19th century Austrian philosopher-physicist Ernst Mach. Jansen goes on, The second condition is that all physical laws have the same form for all observers, regardless of their state of motion. In particular, this should be true for the gravitational field equations, the equations that govern what field configuration is produced by a given distribution of sources. This forming invariance is called general covariance. Einstein had great difficulty finding field equations that are both generally covariant and satisfactory on all other accounts. He originally settled for field equations of severely limited covariance. He published these equations in a paper co-authored with Marcel Grossman at 1913. They are known among historians of Einstein's quest for general relativity as the Eckhoff, which I hope pronounced it properly, and it's German for outline. So he had an outline theory, and that came before general relativity, and the field equations after the title of this paper, the precursor to general relativity with these field equations, is likewise known as the outline theory. In the course of 1913, Einstein convinced himself that the restricted covariance of the outline field equations was still broad enough to make all motion relative. Skipping a bit, as Einstein struggled with general relativity, to get to the relevant bit, Janssen says in a short paper submitted in March 1918, in which Einstein silently corrected some of his pronouncements on the foundations of general relativity. In the 1916 review article, he introduced a special name for this requirement, Mach's principle. This was one of the three principles Einstein identified in his paper as the cornerstones of his theory, the other two being the equivalence principle and the relativity principle. The characterization of Einstein's project given above in terms of the equivalence principle, Mach's principle, and general covariance follows his 1918 paper. This was the first time that Einstein explicitly separated the three notions involved. In a footnote, he conceded that he had not clearly distinguished the relativity principle, identified essentially with general covariance, from Mach's principle before. A few months later, it became clear that even the field equations with the cosmological term do not satisfy Mach's principle. Within another year or so, Einstein came to accept that general relativity did not banish absolute motion from physics after all. And the relevant bit is did not banish absolute motion, so he did not have a solely relativity theory. Janssen goes on, this in a nutshell is the story of Einstein's quest for general relativity from 1907 to about 1920. His frustrations were many. He had to readjust his approach and his objectives at almost every step along the way. He got himself seriously confused at times, especially over the status of general covariance. He fooled himself with fallacious arguments and sloppy calculations, and he later allegedly called the introduction of the cosmological constant the biggest blunder of his career. There is an uplifting moral to the sombre tale. Although he never reached his original destination, the bounty of Einstein's 13-year odyssey was rich by any measure. So what's the point out here? Einstein confused himself, and he's confused lots of other people. But those who are supporters of Einstein like to dismiss that confusion by saying his work was rich. So what we're left with is general relativity is a misnamed theory. So let's go back now to special relativity. And this is from a website, talks about the naked emperor and the science at the crossroads. And this picture might be taken to be Einstein riding on a horse. There's a famous fairy story about an emperor who went around naked, and he thought he was wearing clothes. He thought he was wearing invisible clothes. And so sometimes those who are critical of Einstein compare Einstein to this emperor who goes around believing he's wearing clothes, but really there's no clothes. He's not wearing anything. And that website tells us it's important to note that while Lorentz theory is mathematically indistinguishable from special relativity theory, which it preceded, the basis is different. Specifically, the former is not strictly speaking a relativity theory at all, as it does not reject the ether as a standard of rest by which velocities, distances and times can be given an absolute meaning. As such, it manages to avoid the logical inconsistencies inherent in an Einsteinian universe where light waves no longer have a medium to travel in, and time and length not only dilate and contract in as many different ways as one cares to imagine, but also in two completely contradictory ways at the same time. So it's telling us that Lorentz theory, although it has the same maths of special relativity, is not a relativity theory. Now, special relativity is misnamed as being a relativity theory, and it should really be thought of as a ether theory as well. So really, it's a Lorentz theory. Both are not relativity theory. Both Lorentz theory and special relativity are not relativity theories. Special relativity has been misnamed as a relativity theory, but really, if you sort out all the mess and confusion caused by that, really at the basics, it is just another ether theory, but it has confused all of that. As per this person, Craig, he says the famous theory of Einstein is usually called his theory of relativity, but he thought it should be called theory of invariance, and Craig agrees with that. So really, although Einstein has his theory called relativity, it's not a theory of relativity, it's a theory of invariance. In other words, pointing out once again, it has been misnamed. Now, according to this paper by George Smoot III, he says, one problem to overcome was the strong prejudice of good scientists who learned the lesson of the Michelson-Morley experiment and special relativity, that there were no preferred frames of reference. There was an education job to convince them that this did not violate special relativity, but did find a frame in which the expansion of the universe looked particularly simple. So Smoot is believing special relativity has the preferred frame, and usually when you think of a preferred frame, you are thinking of an ether frame. But this is contrary to what is taught. What is taught on special relativity. They start saying there's no preferred frame, there's no ether frame, but Smoot is believing that those people have been taught wrong. And this is the person, George Smoot III, and he seems to not believe that special relativity is a relativity theory. So one of the conflicts is those who believe in special relativity and general relativity as being relativity theories versus those who think they aren't relativity theories. Where does this conflict arise? Well, as Jansen points out, Einstein was confused. If you look in the history of Einstein's work, he was confused. And that confusion has spilled over from what he's been saying to making people think his theories are relativity theories. But really that's misnamed. They really should not be thought as relativity theories. But but then you've got people who think they are relativity theories arguing with people who think the theories have been misnamed, and that's creating a great deal of confusion. People are not agreeing as to what Einstein's relativity means. Finish, thank you, the end.